You are listening to Deep Neural Notebooks, a podcast where I like to discuss a multitude of topics ranging from deep learning and computer vision to neuroscience and open source software through conversations with experts about their thoughts on the state of their specializations, how things fit into the bigger picture, their journey so far, and the road ahead. I believe that it is through conversations like these that we can boil down the essence of vast resources of knowledge and expertise into more consumable bits that can enrich our understanding of concepts and technologies that are shaping our world. For the third episode, I talked with Michael Droettboom from Mozilla. Michael is a staff data engineer at Mozilla, where he works on managing the telemetry from the products that can be used for improving the user experience and the product itself, while making sure that the least amount of data is gathered from the user instead of snarfing it all up for the sake of it. He specializes in imaging and data, sheet music, scientific visualization, biomedical data, astronomy, and software telemetry. He started his open source journey in 2007, contributing to Matplotlib, while he was also working as a senior computer scientist at the Space Telescope Science Institute. He later went on to become the lead developer of Matplotlib and carried on the vision of Matplotlib's original author, John Hunter. In this episode, we talk about Michael's beginnings, his education in computers and music, his experience with astronomy, working at the Space Telescope Science Institute, and how he got to contributing for open source for Matplotlib. We also talk about his role at Mozilla, the importance of data privacy, and the current project that he's working on, which is called Pyodide, which is essentially a tool to bring the power of data science to the browser. Michael also shared some advice for beginners who are starting out with data science and for communities that are trying to build open source software. So if you like the content, please subscribe to the channel and leave a thumbs up or a star rating depending on the streaming platform. Thank you. Right. So hi Michael, thank you for coming on the show and talking to me.
Thanks for having me.
Right. I loved your keynote at the SciPy conference at IIT Bombay here. And so it's your first time in India, I believe.
It is. It is.
So are you intimidated by the number of people that you see here? I mean, the huge population.
Yes. Mumbai is a very large, very busy city,
Right.
but absolutely beautiful. I've really enjoyed walking around. I went through the Zaveri Bazaar.
The campus is quite beautiful, I believe.
Oh yeah,
Compared to the whole city, it's quite lush and green, and you can sort of walk around freely. But the city,
No, the campus is gorgeous, and I love all the wildlife, the cows and the dogs and and the birds and everybody.
I just saw the cow
walking
sort of
around.
get into the block today where the conference was happening. Not inside the hall, but in the common area. It's quite funny. Right.
It's
So
wonderful.
I wanted to talk to you about your career. You have an interesting career.
Mhm.
You've worked with music. You've been in astronomy, data visualization, open source software, data science, things like that. So how did you start with programming? I mean, and computer science? Right.
So, I think I started programming probably in the third grade, which is about 8 or 9 years old. My friend and I, we had a IBM XT, I think it was, an 8088 computer with probably 640K of RAM and a monochrome screen about this big, and we started programming BASIC because that was the thing that was available at the time, and just we would spend our whole weekends doing it, and I never wanted to stop ever since then. So went to college for computer science, and that's where in grad school is when I started to discover kind of machine learning and data science, and using computers to find patterns that are hard for human beings to find, or hard for human beings to find on a large scale. Yeah.
And so how common was data science back then?
Well, I think the term data science hadn't even been coined yet.
Right.
I went to grad school around 2000, and there, people were just starting to use the word machine learning instead of AI.
What year is this? Sorry.
Or artificial intelligence.
No, what year is this?
This year was 2000.
2000.
Yeah.
Okay.
And artificial intelligence, I think, as a term went, back at least to the 60s. and they made all kinds of big promises that never materialized at that point. And so the phrase AI, I think, had gone out of favor,
Right.
and people had started talking about machine learning instead. Mostly the same sort of principles, but
Right.
obviously new techniques. And I would say even then it wasn't quite clear the promise of what you could do at scale once you have, like we have now, you have access to all this cloud computing very cheaply, and that I think has really revolutionized things. Back in grad school, it was still, you had access to one machine or a handful of machines, and it wasn't until like all that compute was available that all this new stuff kind of broke open.
Right. So, do you remember your first computer science or programming project that you worked on with your friend, like you mentioned?
Oh yeah, we used to. We really wanted to make a game because we were young and games was a fun thing, but we only got to the point where we made the tools to make the game. We never actually got to making the game, and we ended up making all these really sophisticated tools to design the graphics and design the levels and all this stuff, and that ended up being the fun part, and we never really got to making the
That
actual
would have
game.
probably been more difficult to develop the sort of the tools that can make a game rather than using some sort of existing libraries. If there was something as a library back then,
Yeah.
then probably making a game.
Yeah, I mean, there probably were game-making libraries at the time, but we didn't have any money to spend on anything, so it was totally limited to what we could get, freely, and we didn't have internet access at the time either. So,
Right.
yeah, it was
Right.
all do it yourself.
All right. So, your bachelor's and your master's courses. So you did computer science, but there
Yes.
was music also. So had you started to develop sort of a liking for music back then? And
Yeah.
what were the courses like? Computer science and music. How do they go together?
Sure. So, I also have had music most of my life since I was about that young, and when I was looking at where I wanted to go for my bachelor's, I knew I was having trouble deciding between computer science and music, and I ended up going to a place that allowed me to major in both. And there was actually no connection at all between the two departments. I really just had to keep, and strangely, it was on a pretty big campus. This is York University in Toronto. It's a fairly big place, and the music department is at one end of the campus, and the computer science department was all the way at the other end. And I would have classes, and there were 5 minutes between classes, and I'd have to run in the winter. The Toronto winters are much colder than India, I'm sure, and have to run across campus. But it worked for me. And then in grad school, I actually went to a computer music program. So it was a program that actually did integrate the two. And everyone in the program had to have a background in both music and some sort of technical, like either computer science or engineering or what have you. And that's where I started working on optical music recognition, which I talked about in my talk, which is basically the training computers using machine learning to read sheet music.
Okay. So, what's optical in that? I mean, were you sort of training on the sound, on the music, and the audio, or was it sort of some sort of vision-based thing where you? I think I read somewhere that you did it on the music sheets.
Yes.
So, is it a vision problem or is it a speech? Or is a voice problem? Sorry.
It is more of a vision problem. I mean,
Right.
both fields of study exist, right? What I was working on was actually reading the sheet music, so like standard Western European sheet music, and trying to convert that into sound and convert that into some sort of symbolic representation that then you could build a database index out of. So it's not the other problem of like listening to audio and trying to decode the music, which of course people work on as well.
Yeah. So, what data do you give to the machine learning model back then? Or so what is it supposed to find from the database?
So, the input is an image of the page of music that's captured using a camera, and the machine learning techniques I used at the time were not terribly sophisticated. It basically would try to segment the music into its constituent parts, so the note heads and the various symbols that are on the page. It would segment those and then run each of those through a symbol recognizer that's fairly similar to how OCR, like for text, is done, but obviously a different data set. And then once you've done that, of course, the other meaning in the music is where the notes are is very meaningful and how they're spaced on the page. And that I think at the time I wasn't terribly sophisticated in machine learning, and so it was a lot of just ad hoc little heuristics and whatever to try and make it all work. I think if I were doing it now, I think trying to use some sort of neural network to actually figure out the patterns on their own, like a more unsupervised training system, probably would have worked. Because the problem with all the heuristics was there was always one more heuristic that you had to add to make it work.
Right.
And so you're constantly just getting it close and then running it on more data and realize it's broken on that data. Okay, so I'm going to have to,
Fix
you
that
know,
and then-
yeah.
Right.
And I think the other sort of light bulb that came up after I was working on this problem was a colleague of mine from them, Christoph Dalitz, realized that there's a lot of sheet music now that's produced electronically. So it's produced from computers as a PDF. And the nice thing about that is you already know the output because they've created the music electronically, and we know what the music is supposed to be.
Right.
And so with that kind of training set, you have both the image and the sound that you're trying
Both
to
are
create.
digital now, and then you can
Yes.
sort of...
And so then you could train a model on that because you have both
Right.
the input and the output. When I was doing it, I only had the input and my own brain's knowledge of what the output should be, and that doesn't scale. Right. Yeah.
You also, I think you compose music. You also
Yes.
performed once. So
Yes.
how was that? I mean, I don't see many computer engineers into music. So how was that?
So I really enjoy the performing. I don't do as much now as I used to, but I kept up with it for many years after I left school. I was in a group called the Peabody Renaissance Ensemble in Baltimore in the United States for probably almost 10 years. It was a fantastic group. And so I enjoy the performing. When I was in school, actually, I was studying classical voice, so like Western opera, and what I learned from that experience is actually I really enjoyed the music and I really enjoyed it singing it. What I really didn't enjoy was being on stage and getting dressed up and all of the acting parts. And so I realized, okay, maybe this isn't kind of the career for me. And thankfully, I really liked computer science as well, and so that's kind of taken over.
It's quite interesting how you were working. So this is, I think, you performed in 2010, I think. So at that time you were also working for a company, also contributing to open source, and then also sort of playing music, composing music, performing. So how do you, I've even seen it throughout your career, how you can sort of balance contributing to open source and also working for a company. So how do you sort of balance both?
Well, I've been really lucky. I don't know how typical it is, but most of my career I've been paid to work to work on open source at my job, which really, really helps because then my job is to contribute to open source and build open source projects, and my employer is totally okay with it. They've asked me to do it, right? Yeah. I definitely have a lot of sympathy for folks whose maybe day jobs are very closed source, but they really believe in open source, and so they do it all in the evenings and weekends. That's a lot of work, and certainly in my evenings and weekends, I generally don't feel like doing more computer programming because I've already been doing it most of the day. So that's hard, and I think, to answer your question, I've just mainly been very lucky that my employers have paid for it.
So when was it first when you got sort of introduced to open source programming?
Probably, I was certainly aware of it during my undergrad in the late 90s. And that was, I was already running Linux at that time and sort of saw the power of having an operating system where any part of it, if you wanted to and you had enough time, you could tinker with it and fix it and modify any one part of it. Like, I saw that power, but it probably wasn't until grad school where I was working on more sophisticated projects and realizing, someone else has already solved this thing, I can just grab that, and I'm going to solve this part, so I'm going to make that available to everyone else. And the power of like not everybody having to do it all themselves each time. That's kind of when I got hooked on open source and understood that, like, for the greater benefit of society, this is a great way to develop software.
Right,
If that
right.
makes
So
sense.
was it around the I mean, so this you started with open source around. I mean, you learned about it and you felt that it's a good thing back in grad school,
Yes.
right? So let's talk about Matplotlib now. I mean,
Yeah.
when did you first get? When did you meet John Hunter? When did you
Yeah.
sort of? How did that sort of process start?
Sure. So I used Matplotlib on this music project. That's where I first became aware of it. I used it to sort of analyze what was going on in the data and trying to improve the models. Um, but it wasn't until I started working at the Space Telescope Science Institute, with where my boss was Perry Greenfield. My first assignment there was to work on Matplotlib. They said
Hmm.
what we want to do is we have these things in Matplotlib that we need to improve for our
Hmm.
own work. Could you please work on that? And while you're working on that, go ahead and triage some bugs and help people on the mailing list and do sort of the
Hmm.
open source maintenance stuff. And at, at at the time, and even a little bit now, Space Telescope has been very big on supporting the Python, NumPy, SciPy ecosystem.
Hmm.
They did a lot of the early development of NumArray, which is a library that preceded NumPy. And so, yeah, it was a really good place at the time to support open source and be working on open source. And I met John Hunter just sort of over the phone. We would have phone meetings at that time, and I hadn't met
Okay.
him in person, but
Right.
we would have meetings on the phone about various technical things and what we should be doing. At that time, he was quite busy in another job, and so he was working on it less and less, and I think was
Hmm.
appreciating other people coming in. And then I think I met him in person for the first time at SciPy probably 2008, I would guess,
Hmm.
which was one of them in Pasadena, California, at Caltech, and just a great guy. I mean, immediately, one of the things that he taught me about open source that I think is really important is there's there's very little reason to be protective of commit rights to your repository. I think a lot of projects or a lot of original authors, which he is of Matplotlib, are sort of very protective. Like, this is my project, and yes, I can have people contribute to it, but I want to have final say about what goes
Hmm.
into it. And he had a very different attitude. He was like, if somebody comes and they are motivated enough to want commit rights, I'm going to give them commit rights. And he says, I've been doing this all along and I've never regretted it. No one's ever made a mistake so serious that it couldn't be fixed. Sometimes maybe you have to go back and say, yeah, that was a bad idea. Let's revert it. But really, there's always a benefit, I think, of being as inclusive as possible, as early as possible on open source projects.
Right.
Yeah.
It's quite a nice story. So,
Yeah.
Matplotlib has sort of been relevant throughout
Mm-hmm.
the whole period. So, were there any alternatives to Matplotlib when it started, and how has it been able to sort of be super relevant even now? I mean, it's one of the most commonly used Python libraries. So,
Yeah.
so you are the lead sort of developer, or you were the lead developer,
I no longer am. I don't have a lot
right?
of time for it
Right. So,
these
but you've
days.
seen
Yeah.
it grow. So,
Yeah.
what do you think were the primary reasons that sort of helped it grow along the way?
So my memory is probably going to be a little vague way back then, but I do remember there were some alternative Python plotting libraries at the time. Many of them were designed for one particular GUI toolkit or one particular operating system. And I think Matplotlib was the first one that said, we're going to have a bunch of different backends. So the backends are basically how it communicates with different GUI frameworks and different operating systems. So, Matplotlib works with GTK and Qt and TK, and there's one specifically for Mac OS, and I think there at one time was one specifically for Windows. And what that meant is anybody could run it. It didn't matter what their application technology they were using was. Matplotlib would work with it, and I
Hmm.
think that was a big part of its success and why it took off. I think those things are becoming less and less relevant now because as the web is sort of becoming the dominant platform and most people are using Jupyter notebooks to do their data science and stuff, like having a Qt backend is less important.
Right.
It is still important in some use cases, but I think that was a big part of success first, and then also it's included a lot of features over time. Like, again, I think with John's attitude, like, if you have a feature you want to add, let's just add it. Let's get this thing to include it. So it has these very sophisticated Sankey diagrams that are used in EE, and it has great violin charts, and it has all these different plot types, and they're all just there. I think that's a real strength. From a developer perspective, I know that that's sometimes tricky on us, particularly like the core maintainers when I was a core maintainer, because every change that you made to Matplotlib, there was so much code in there that the likelihood of breaking something was really, really high. And so one thing I've talked about for a number of years and haven't had the time to do, but I talk about this with Thomas Caswell, who is the current maintainer. I've had conversations about this. One thing we'd like to do at some point is re-architect it so it has a set of core functionality with a really clear API about how to use that core functionality that wouldn't change very often, and then have all these plot types kind of go out into separate projects and let other people maintain those, and they would just work against this stable API, and that way we as Matplotlib, I guess maybe I'm not part of the we anymore, but the Matplotlib developers don't have to maintain all of it all the time, and it could be more distributed.
Right. So Matplotlib has been exclusive for Python. So at any point of time during the timeline, was it considered to sort of allow other people to build, or to build for other languages, to have Matplotlib for other languages, Node, JavaScript, Ruby, and things like that?
Yeah, well, I think it would be a great idea. I mean, one of the things that you see, not just in data science, but in software engineering in general, is these languages tend to create silos of technology. Do you know what I mean? Like, if you're a JavaScript programmer who uses Node, you're going to use the JavaScript HTTP library, even though maybe some other language has a better one. You're just going to use the one that's in that silo. And so definitely in the Python world, you have the silo of all the Python tools, and they're very good tools, but it's hard for us to collaborate with the R community that has good strengths in other areas, right? So it would be, I think, as part of this re-architecture, if you're going to take it one step further, you would have a core that is probably written in something like Rust or C that's very, very portable, and then wrap it for all these other languages. So you have Python bindings and Ruby bindings to it, and then et cetera, et cetera. And then it could be used by all these things. Obviously, this is a lot of work, and someone needs to do the work.
But probably focusing on one specific language would, since there's a lot to cover, and like you spoke of the problems, that it has to be quite inclusive, and then you have to maintain the code and things like that. So it's probably better if you can just focus on providing the best sort of software for one language, and that's probably not caring about the other languages.
That's true. Certainly from a time spent, value versus time spent, focusing on the one thing was the right choice, and probably still is the right choice. And interestingly too, Julia, when they started, didn't want to rebuild a new plotting library in Julia, so they actually include Matplotlib, and there's a very sophisticated set of bindings between Julia and Python so that you can do your data science in Julia and then pass it to Matplotlib for your plotting, and it works amazingly well. So there are kind of I don't want to call it a hack, but there are sort of tricky ways to make that work too that have been successful.
So one of the most common ways is, using Pyodide. Not the most common, it's coming up. So we'll talk about that later.
Sure.
But having been the lead developer at Matplotlib, what sort of advice would you give to people who are, groups of people who are coming together and making open source software, just starting out, probably trying to be as successful as Matplotlib, NumPy, things like that. So what sort of advice do you think would be helpful to people starting out?
Well, I think a lot of these tools like Matplotlib and NumPy are successful because their initial developers were scratching an itch and an interest that they had themselves. Like Matplotlib was made, as I understand it, by John Hunter for his neuroscience work that he was doing at the time. He couldn't find a tool to do the neuroscience work that worked well enough, so he started Matplotlib. And he had sort of a very strong personal motivation. And I think in open source, particularly if you're volunteering your time to do it, you really have to be committed to it, and you have to have like a personal passion for what you're doing. So I think it's important to not set out to like, what could I do that would be super successful? Just set out and do what is important to you, and I think the success will come from that, if that makes sense.
Right.
Yeah.
So have a clear goal of what you want to build.
Yeah.
And be sort of motivated about it, something that drives you, and then
Yeah.
Communicate with people. And
Yeah.
make sure that the thing. Everything falls into place. And
Yeah, because I think if it's something you're passionate about, you will do a very good job. And if it's something you're passionate about, there's a very good chance there's a lot of other people that'll be passionate about it too.
Right. Will come along and help you get there.
Exactly. Yeah, be confident that your excitement is real and shared.
Right.
Yeah.
And only then sort of the people who are working with you, they'll be able to sort of get the excitement.
Yeah.
Right. So let's talk about your experience in astronomy.
Sure.
So you work. I always get the name wrong, so I'll just read it. So you worked at the Space Telescope Science Institute.
Yes.
And you were a senior computer scientist there for around 8 years. Mm-hmm. So what was your work? There.
Yeah. So it's sort of an interesting story how I got there. In 2001, I was at a conference presenting on the music stuff.
Okay.
And the conference was in Los Angeles. I lived in Baltimore at the time. So Los Angeles is on the West Coast. Baltimore's on the East Coast. It's a 4-hour flight, right? And I was at this conference, and I was just meeting people and chatting to people. And I met this guy, Perry Greenfield. Okay. And I said, yeah, I'm in Baltimore. He says, yeah, I'm in Baltimore too. And we realized that we actually worked about 2 blocks from each other in Baltimore. But we hadn't met each other in Baltimore. We met each other miles and miles away. And so years later, when I was looking for a job, I just decided to email everybody I knew who was kind of related to computers in Baltimore. And he wrote back and he said, you should come apply here at the Space Telescope Institute. And I said, well, I know nothing about astronomy. Is that going to be a problem? And he said, no, you'll figure it out as you go. And so, I interviewed and applied, and it turned out to be a really good fit because it was really fun to work at a place where people are very passionate about astronomy. I knew almost nothing about it, but I could ask anybody the things I needed to know, and they would recommend books, and I would just learn the bits I needed to know as I went along. I would sort of get assignments like, we need to do this. What was I assigned that was the first like scary thing? Oh, we need to build this library for astronometry, which is actually it's like the geometry that you use for astronomy. Okay. So we need to build this library for astronometry to do image mosaicing, and I just went, I don't know what any of those words mean. Right. And slowly, surely, you go to the library and you figure it out, and that's really fun. It's fun to be in a job where you feel like you don't know what you're doing all the time.
So you're coming from a musical background.
Yes.
And then sort of completely starting fresh. Right?
Yeah. Yes, totally starting fresh with the domain, but a lot of the skills around machine learning and image processing and Python, certainly from before, definitely translated right in. And the Space Telescope Institute was a real early proponent of pushing Python for doing scientific computation. I think before that, common things were Fortran, maybe C++, and they were really pushing for Python because you get a lot of people in this field who have a classical astronomy background, and they're not as excited about computing as I was as a kid, and so for them the computing is a tool. And they want something that is easy to learn, that they understand, that's not going to be surprising. And Python is a great fit for that.
Right. Yeah. So what sort of computer science knowledge is used in a project like this?
Well, a lot of things. So the group I was in there was called the Science Software Branch. So it was the team that made software that the scientists who were analyzing images would use. Okay. So when you collect data from the telescope and it comes down, there's a bunch of things that need to happen. The first step is things like calibration, which is basically correcting for all the things in the telescope itself that cause the data to not be right. So
the Hubble telescope.
The Hubble telescope. Yeah. So, things things are just, there's always a bit of a warp in the lens, and there's all these things you have to correct for. So calibration is the first thing, and then after that is sort of all the analysis of like looking for patterns, looking for various things in the data. And so our team built that software, which is all open source, and scientists who work with the telescope are expected to use. The model there is that the Space Telescope Science Institute sort of supports the telescope, but the scientists that use the telescope are all around the world. What's one of the really cool things actually is anybody can propose an observation with the telescope. They write it's like writing a formal proposal. Like they say, I want to look at this object at this time for this long, so that I can learn this thing. And there's a whole committee, much like a program committee at a conference, that decides which of these proposals are scientifically valuable.
Right.
And then they get the time on the telescope and they get the images. And there have been people from all kinds of institutions. It's not just top institutions that get the proposals, because it's all just on the merit of the proposal. Right. And so it's pretty cool.
So you essentially make a request to the committee to allow, you to use the data that's being captured from the telescope that's in the
exactly.
space.
Yeah, you sort of make a request for scheduling, it's called. So meaning you request some time on the telescope to have it pointed at a particular object and using a particular instrument and collect that data. Yeah.
Right. So you also worked on adaptive optics. Mm-hmm. So I believe, like you mentioned in the keynote, it was so there were some sort of takeaways that you could, that you could gather from your work at the Space Science Institute, Space Telescope Science Institute. And so how was that process? I mean, you explained it quite well in the keynote there. Sure. But could you again sort of talk about it? How all the things that you learned there, how you could sort of apply it at the National Eye Institute, I believe?
Yes. Yeah.
Right. So what was the work like?
Yeah. So adaptive optics is something I had learned about. I'd never really worked on it too much at Space Telescope, because it's actually a technology that's most useful for ground-based telescopes. And the Space Telescope Institute is really only concerned with telescopes that are in orbit or off the Earth, right? But I was working on some side projects where I learned about the concept and was reading about it and thought it was really cool. And then, again, as has kind of happened, like just by random chance, years later I was looking for a job, and they were very interested in the fact that I had done astronomy. And I didn't even know why until I went to the job interview. And they said, well, we have this new device that we're using to scan retinas, and we're using adaptive optics. And we got the idea from astronomy, and because astronomy, we're hoping that you'll be able to help us, improve the system and work on it. And again, it was another job where I didn't know anything about medicine, didn't know anything about the eye.
I love just how you switch between science has varied sort of fields and still gel in so well. And I mean,
yeah, well, I think that's what's fun about computing is in this day and age, all science involves computing. And so for me, as someone whose first love was the computing itself, I've been able to bring that into all these different fields, because they all need computing now, no matter what field it is. So anyway, worked for about a year on that project, and again was working on the problem that I'd done a lot of at Space Telescope, which was stitching the images together that you've made with adaptive optics or with some other sort of optical thing. And interestingly, the problem with the eye is much, much harder, because at least with the Earth, you do have the atmosphere and you have to correct for the atmosphere, but the Earth rotates in a very slow and predictable way. The eyeball is constantly in motion. And the whole point of this imaging is to image, people with who are awake and their eyes are working so that they can, figure out what's actually functioning in the eye. And so if you ask someone to keep their eye really still, it's pretty hard. Like nobody really can do it. And so the data tends to be very blurry. You have these very short moments where it's still enough to get a good image, and you have to find those. And
what's the data like? I mean,
so it comes to me at the analysis step basically as a movie. So when they're scanning the eye, they have a video camera at I think it's at about 60 frames per second. So high speed, but not super high speed.
A camera in front of your eye?
Yeah, it's the whole system actually is this giant table because it's a prototype and they haven't miniaturized it down yet. And there's a bunch of things going on in there, but in there is basically a standard camera that's shooting into the eye, and then the whole adaptive optics system is off to the side, trying to analyze the fluid that's going on in there and correcting for it in real time.
Okay.
And so then the data I would get to work was off of the camera as a video file, and one of the first things you have to do is separate all the blurry images that are going to be useless from the ones that are still, and then very carefully try to figure out how they all fit together, because each little picture you get is of a very small part of the eye, and you don't know even where it's pointing. You don't know where the eye was pointing at the time, so you have to actually look at a bunch of images and just try and it's like a jigsaw puzzle, literally, like a jigsaw puzzle where you don't know what the end result is supposed to look like, right? And you just have to look at each individual piece and find enough similarities until you can stitch it back together.
Right. It's quite interesting how something that you learned in astronomy, trying to probably understand the space, I mean, for something that's so far out, using the information that you gathered from there and trying to sort of understand something that is so close to us, and I mean, so from something so huge to something so minute, and I mean, quite localized that way.
Yeah.
Right.
Yeah.
Quite cool. Right. So now you're a staff data engineer at Mozilla for the last 2 years.
Yes.
So the first question I'd like to ask is, how does it feel to directly or probably indirectly work on a product that's being used by millions of people around the world?
Occasionally, it's a lot of pressure because, but only very occasionally, because when things do go wrong, they can affect a lot of people. I think I actually so far have mainly worked on a product called Firefox Preview, which is still in a sort of pre-release stage. Of early next year, it's going to become the main Firefox for Android.
It's in beta right now?
Yeah, it's in beta right now. So it doesn't have a ton of users, and they're beta users, so they do kind of have an expectation that things might break now and again.
Right.
So that's a lot less pressure. But eventually it will be released, and then, I think because I'm on the data team, the things I worry about most are not so much the product breaking, but that us accidentally collecting more data than we should be. And we have a lot of discussions on my team actually about they usually start, okay, there's a problem in the product. We don't know what's going on with it. How can we collect the minimum amount of data in order to get enough insight into what the problem is, but not so much data that we're ever invading anybody's privacy? And that's just kind of like the constant weekly discussion there. And I find it really rewarding that that's how they view data. So many tech companies really don't have that perspective. This sort of, let's collect as much data as we can and target ads, and because that's how they make money. Mozilla doesn't make money that way. We really want to be like a trusted personal agent to the web. Because it's the window into people's entire lives. We want to give people an option, use our browser, and your privacy will be respected. We're only collecting the data so we can make the product work well and improve it.
How does Mozilla sort of strike the balance between trying to provide the best consumer experience and also at the same time respect the user's privacy? So is Mozilla in this process, is it missing out on something that might help in providing a better experience? Are the users sort of missing out on something probably in the process of securing their data? I mean,
that's a really good question. I would say that I think there's a balance there. I think, perhaps if we were collecting more data, we could do a better job at providing exactly the product that people want. But by collecting that more data, we would be sort of breaking people's trust, and therefore, I think whenever we have those kind of thoughts or discussions, we always err on just not collecting the data and trying to find another way that we could, determine what users want or market to users that doesn't involve that. I should add that, I'm an engineer on the data team, and I I have these opinions, but they are mine. I'm trying to represent everybody's opinion as best they can, but I'm not officially representing the data team.
Right. So also possibly something that you could, that's how I think. Probably allowing the user to sort of have an option. I mean, they could sort of in some way communicate that back to the team.
Yeah.
That okay, I probably would prefer the more sort of recommendations for something or. Probably they might value their customer experience more. So probably Mozilla could give them an option to let that sort of trade-off happen.
Yeah, and there is a history of that. Like right now, you can opt out of all data if you want. We've talked about having sort of more fine-grained opting into certain things and not other things. It's hard to like communicate that well enough that people really understand what they're doing. But I definitely agree that there might be cases where people are willing to give up a little privacy in exchange for something that they value. It's something that it might be done, assuming we could do it in a safe way that made sense. I mean, I think the classic fear is if you ever look at Facebook's privacy page, there's a million settings in there. It's not at all clear about what any of them do, and it sort of feels like that's a bit that way on purpose. They want to deliberately confuse people, and I would hate to ever be like doing something like that,
Right. So, what is your role at Mozilla specifically? I read that you work on the telemetry side.
Yes.
So, let's say if I use the product that you're working on, the preview, Firefox preview.
Yeah.
Right, so, how are you able to sort of? What is your role? I mean, basically, with what I do in my browser, I mean, how are you sort of able to make sense of that?
Sure. So, I work on a project called Glean, which is sort of an internal library for collecting telemetry, and Firefox Preview just happens to be the first product that we're rolling it out in. But we do plan to eventually roll that out across all of our products. And the reason we're doing that, one, is so that all of our products will collect telemetry in a sort of consistent way, so that we could do data analysis across products, and doing that would kind of make sense. Right now, all our products collect telemetry in slightly different ways, and it makes the cross-product analysis hard. The other reason we're doing this is the Glean is designed to help software developers think about these kinds of lean data issues I've been talking about, and sort of force them to do the right things as much as we can. Well, maybe force is too strong a word, but encourage them to do the right things and point them in the right direction. So whereas our older telemetry library would encourage people to just return random strings of data that could contain anything, we're now trying to have a richer set of data types like counters and UUIDs and things that actually mean something, so that they're thinking about what kind of data they're collecting. And it also enforces that every single piece of data that gets collected has to have a data review. So we have an internal process and a team called the data stewards, who every time a software developer wants to add new data collection, it has to be run by the data steward team, and they have to sign off on it. And that includes a public process too. These are always in public bugs on the open internet. So anybody can come along and see what's being collected and learn why and learn how and those sorts of things. And this new Glean library makes it impossible for people to start collecting new data until that process has been signed off. So
in the word Glean, does Lean stand for the lean data practices that Mozilla talks about?
Yeah, I mean, it's definitely, I think the English word glean means to like learn and discover things, which is what telemetry is about. Right. But yeah, the fact that it has lean in there as well is also cool. And one of the reasons, we picked it.
Right. So one more thing you're working on, probably you're working on the most right now, is a project called Pyodide.
Yes.
So you spoke about it in the keynote that you gave. So could you explain it in one line?
Yeah.
What Pyodide does? So
Pyodide is the whole scientific Python stack compiled to WebAssembly so that it can run in a browser. So WebAssembly, for those that don't know, is a new sort of bit code, like an assembly language that's designed specifically to run in browsers. And so you can compile things like C and Rust and those compiled languages down to WebAssembly, ship that to the browser. It then compiles the WebAssembly to native code, and runs that. And it runs it entirely in the browser sandbox, so it's safe. It's not just like running an arbitrary executable on your machine. It's all runs in the same browser sandbox, which is a pretty well understood sandbox at this point.
Right.
Yeah.
So, what's the motivation behind building something like this? Why do you want to bring Python to the browser? I mean, that's probably
Yeah.
a common question that people would ask
Yeah.
you.
So the motivation for us is to do data science specifically. It's all started sort of as an internal tool for Mozilla's data scientists to use. And we wanted to be able to create a way that people could work in Python and do data science in Python, but then very easily share it over the web. And not to have any sort of complicated backend infrastructure, or people don't have to install anything on their machine, which is kind of the choices that are available with Jupyter right now. So by putting Python in the browser, all you have to do is visit a website, and it automatically comes down, and it's all available to you. There are some downsides to that. It means that website takes a while to load, takes a fair bit of memory. But for us, the trade-offs have been pretty okay so far. A lot of people often ask, can this Pyodide thing be used to build web applications? And the answer is, of course, yes, it could. You could build something like Gmail or a really sophisticated web application with it. You probably wouldn't want to, because it's not a very efficient way to do it. I think it only really comes into its own if what you're trying to do is expose the Python language to the end user that visits the website, because they want to use Python and interact with it. If the Python is kind of hidden from the user as an implementation detail, I'm not sure it's the right choice. If that makes sense.
So, to get some sense of how Pyodide works, so basically, using WebAssembly, you boil down the Python interpreter
Yes.
into bitcode.
Yep.
That can work on the browser.
That's right.
Right. Quite good.
Yeah.
So, one more common question that probably people who have seen what Pyodide looks like, the documentation, things like that, how is it different from Jupyter Notebook?
So the main difference is, with a Jupyter Notebook, you have a web interface, obviously, but behind that is a server that's running outside of the browser, sometimes on your own machine, oftentimes it's somewhere in the cloud. And then behind that server is the kernel, and the kernel is where the actual work happens, the actual data science computation. In Pyodide, the kernel is moved into the browser. So the whole thing actually kind of works. Once you've downloaded a Pyodide website, you can disconnect your internet and it will continue to work, because it doesn't have anything going on, any requirement of talking to a server. Yeah.
So, like, what are the challenges that you face? Bringing something like, so browser is sort of like you said, it's a sandbox environment. It's a constrained environment. It has its own rules. So, what advantages probably, and what challenges does that sort of bring into this scenario? Yeah,
so probably the biggest challenge is it's really hard to get to data on your local machine. You can't just load files off your file system. So one of the things we've done in Iodide is we have sort of a nice upload workflow where you can drag and drop files into the browser, and they get uploaded to the Pyodide server, and then they are available to you. That's probably the biggest challenge. The other challenge for some applications is that the networking is pretty limited in a browser on purpose in order to be secure. So you can't just open up a raw socket like you can on Unix and start writing things to it and talking to services around the world. All you can really do is talk HTTP or HTTPS to things. And so it does mean that Python tools that are kind of network-centric are probably never going to work. Yeah.
So Pyodide came from Iodide.
It
So
did.
what was different? I mean, why did you sort of port to Python? And what was the original Iodide like?
Yeah. So the original Iodide started at Mozilla before I got there, by Brendan Colleran and Hamilton Ulmer. And their vision was trying to solve a lot of things around sharing data science work at Mozilla that they were having problems with. Like, data scientists would kind of work in notebooks, and then they would have to convert that to a Word document in order to share it with their manager. And then if they had to go back and do it again, it's a very manual process. And it just sort of, there were a lot of speed bumps in the way. So they thought, let's build something built around the web, which does a really good job of sharing things with people generally, and a really good job with collaboration, and try and build something that's built like the web. I hope I have their vision stated. They had it first, and they're maybe better at it. but because this was a web-based tool, everything initially was all JavaScript, because obviously that's the easy thing to do in a web tool. And when I got there, I said, well, wouldn't it be great to have Python? Because the data science libraries and the whole ecosystem is not really there in JavaScript, but certainly it is in Python. And we sort of said, oh, yeah, okay, wouldn't that be nice? But that's going to be way too hard. And we dismissed it for a while. And then we were talking to some people on the WebAssembly team at Mozilla, and they said, you should just try compiling the C interpreter to WebAssembly and see what happens. And I said, that's going to be really hard. I'm sure we're going to run into all kinds of problems. And as it turns out, it only took a couple days to go from zero to having something that basically worked. And like a lot of computer projects, you get to that 80% really quickly, and then that last 20% takes you forever. And so that's where we are now. All these details of getting it better, faster, more stable is still very much ongoing. But that initial just getting something that turned on and said hello world didn't take that long. So that's a testament, I think, to both WebAssembly and how well it works, and Mscripton, which is the compilation tool chain we're using to do it. Like, it really does provide a lot of things for you.
Right. So how does this improve collaboration? I mean, it allows Python to sort of harness the capabilities of the GUI that probably a website provides. But other than that, how are you thinking of, I mean, I believe the core vision was to allow two data scientists, or probably two different people, to sort of share the results of their data science experiments, something close to that. So two people sort of living in different countries, how can they use Pyodide to, I mean, share the results and sort of work, sort of collaborate? And is that possible? I mean, or is that something you're looking to sort of achieve?
So I think part of it's already there, and then we have a vision for where it really needs to go. So the part that's already there is it does a good job of allowing the data scientists to do their exploration work, find some pattern in the data that's interesting, and easily turn that into a report that they can share with their manager. And not to stereotype managers, but when I say that, I mean someone that's not going to be looking at the code, or maybe is not deep into data science, but they want a report with graphs and pictures to make a decision. So that part of the flow, I think, is working pretty well already. Where I think it needs to go next in terms of collaboration is to have things like commenting, maybe better version control, things that Google Docs does very well. A lot of things that it does, we would really like to have. It's sort of, as we've started to use it internally at Mozilla, I think that's like one of the most highly requested things is as we share these notebooks, they go, I really wanted to just comment on this one thing, but I have to write you an email because there's no commenting in it, And so it would be nice to fix that. And we definitely plan to.
So like you said, it's probably difficult to do the computation on the browser. So there are some restrictions for that. So something that Google Colab does, I don't know if this is a common question or not, but so they allow you to sort of use hardware mechanisms. I mean, hardware, not mechanisms, sorry. Hardware services that they have. So good GPUs, good computation, and sort of remotely access that. So is this something that you would like to work on? Or I mean, since you're working on data science and since competition is an important part, so would this sort of help people to be able to, do the same thing? I mean, I know it's running on my browser, but in some setting, would it be possible to do this computation on an instance that's running somewhere in the cloud?
I definitely think that's part of the long-term vision. I think right now you're totally right about the trade-offs. Like something like Google Collaboratory or any of these hosted Jupyter solutions, they have access to big cloud compute resources with GPUs and all kinds of stuff that is generally going to be a lot more powerful than your laptop sitting in front of you, right? So we're definitely playing in a different trade-off space where like we're very close to the user, but we might be far from the data. We don't have access to big compute, and we don't necessarily have access to big data sitting right there either. But there is a long-term vision of WebAssembly amongst the WebAssembly team at Mozilla to do sort of server-side WebAssembly. or I guess that it's often called browserless WebAssembly.
Okay.
And what that would allow you to do is run arbitrary code on cloud computing resources, and it's all sandboxed just like a browser.
Okay.
But in a way that would probably be a lot more efficient than things like Docker, which is what people use for that now, right? Because Docker, you have to have this whole Linux operating system just for your Docker to run your code in it. And you have all this extra stuff that you don't necessarily need. And having just a really small WebAssembly kernel where you could run arbitrary, untrusted code in a sandboxed way would let you run this on the cloud very efficiently.
Right.
So it definitely is kind of a long-term vision of maybe you use Pyodide to prototype on your laptop, get something working, and then you could take that exact same thing, because it's all WebAssembly, and run it in the cloud easily when you need to scale up and run closer to your data or run on more data. I know that's something that Mozilla is very interested in as a long-term strategy for WebAssembly. So I think it will come to fruition. And there's already service providers out there that are offering WebAssembly compute nodes.
So isn't WebAssembly primarily for running sort of different languages inside the browser?
Yeah.
So in this sort of a setting, I believe browsers sort of get out of the picture. Now you're just running code on the machine in the cloud.
That's right.
So that is not, I mean, the primary thing about something like Pyodide is the fact that it can run Python on the browser.
Yes.
So that is probably something that you can explore later. But
yeah,
I mean, as of now, you can just work on the stuff that you're doing right now.
That's correct. I mean, right? Yeah, I think maybe in hindsight, WebAssembly was misnamed. I don't know if people would say that. I think they wish it was having the word web in there is maybe more narrow than the vision has become. I would say WebAssembly has become more of an idea, more of a way to run untrusted code, like arbitrary code that's provided in a sandbox. So it's like a sandboxed assembly, maybe. I'm terrible at naming things, but yeah.
Right. I love how not only does it bring Python into the browser, not only does it allow you to sort of do data analysis on the browser, but it also allows you to sort of have the sort of, like I mentioned before, the GUI capabilities of something like a browser, the capabilities of a web page, and sort of allow Python to sort of get in there and to allowing the web page to sort of speak for the results, and which can be sort of shared better. So I love how you're bridging web development and data science. Right.
Thank you.
Cool.
Yeah.
So right. So you've worked on academia also, and in the industry also.
Yes.
And probably if on open source software also. Open source software and industry are a little related.
Yes.
But so what can you draw any comparisons between the sort of workflows in an academia setting and in an industry setting?
Sure.
And in a sort of open source community setting?
Yeah. So I don't think there's any like silver bullets in terms of process for software development that make like Mozilla any different than academia. I think the main difference is Mozilla just has a lot of software developers. There's 1,800 employees, I think. I don't know how many of them are software engineers, but there's a lot of people working on Firefox, and that I think is probably the key to its quality, because anything you're going to do to create more quality, testing, Q&A, proper design, all these things, they just take time. They're not magical. And I think the biggest difference in academia is there's just far fewer people working on these projects. And so it's not that they're any less skilled or any less talented, or any of those things. It's just there's fewer of them, and therefore there's less time. And I think therefore it often becomes, which corners should we cut? It's a reasonable thing to do. Like, am I going to test a little less than I need to, or whatever, just to get it done? Well, yeah, that's what you have to do to get it done. So I think that's the biggest thing I notice. I also have had a couple jobs in sort of more closed source environments, And there, I would definitely say there is a strong sort of like cultural and quality difference. I think when people are writing code that the world may see, they tend to do a better job and are more careful. I mean, maybe I'm stereotyping based on anecdotal experience. I guess I am, but in my experience, closed source companies they tend to just race through things, do the minimum thing that's going to work, and hope that no one ever sees it.
Right.
And one thing I really like about open source is people generally take pride in their work because they're sharing it with the world, and it's important to make the project work for the next people that are going to come to it, so that you can build a community. If your code is too obtuse or too hard to understand, people won't contribute to it because it's too much effort. So I really do think it helps us with quality on a number of levels. And so Mozilla is this really, I think, special place in that it's very much an open source first company, but they also have, we don't have the scale or the size of a Google, for example, but we have sufficient resources to do our job well as well. So it's really nice.
Quite good. So before I close, I'd like to ask you about any advice that you can give to sort of beginners in computer science and data science. So, and given that how you've sort of explored quite a lot of number of fields that sort of go hand in hand with computer science. So, is there any recommendation that you would like to give to, to explore things, to go out of their comfort zones like you did at multiple points of time in your life? So how can they get into something like this, and how can they do better in their careers probably?
Well, I think for people that are interested in data science, the number one thing I would recommend is learning statistics. It's the thing that I don't think I had enough experience in until sort of later in my career, and I've had to learn it as I go. But I really wish I had taken more statistics at school when it was easier to learn and there was proper teachers around. I just think that the difference between the data scientists who really understand statistics well and those that don't, those ones who understand statistics well are just able to be so much more productive and effective. So that I think is easily 50% of the job of a data scientist, if not more. And outside of that, I think collaborating on an open source project that is relevant to the domain that you're in or that you're working on is a great way to understand better how it works under the hood. Like if you're using scikit-image to do image analysis and it's not quite right, going in there and reading the code and seeing what it's actually doing and then trying to fix it is a great way to understand the like fundamental principles and not see everything as a black box. People shouldn't be afraid of going in and reading open source. Sometimes you will go in there and you'll go, I have no idea what this does. It's which is fine, but it can be a great learning experience to go in there and try to do it, and I really recommend that. I think a lot of people who maybe have more of a background in proprietary tools are just used to the idea that everything's a black box and you can't figure it out anyway. Right. So don't forget that open source, it doesn't just mean it's free, and it doesn't just mean that it's from a community. It also means you can go in there and look at it and try and fix it or learn from it.
Right, and about switching careers. Not careers really, but switching fields and sort of putting yourself out there into sort of more challenging scenarios. And it obviously helps us to become better overall when you see it in hindsight. But how could someone figure out? If it's the right time to switch, probably how do you know when you can sort of make a transition to a different field?
Yeah. I think that's a hard question to answer because I can give you like anecdotal things from my own life, but I don't know how universal that would be. I just think for me, as long as I'm learning something that's interesting and a little bit challenging, I'm happy. And so it doesn't matter to me terribly much what that is. So I think just developing a passion for learning, and maybe when you're in school, learning how to learn rather than focusing on learning what you're learning right then,
Right.
is a really important skill. Like, for example, you're in your calculus class in first year calculus. Don't just focus on the formulas and the integration. Try and understand what it is that's interesting you about it, or what it is that's helping you learn, because those skills will take you through
And that's
your whole
probably
life.
something that it's not taught much in schools about how to learn, probably.
Yes, yeah.
That's something probably.
Yeah, I think really good teachers are really good at and attuned to that. So, yeah, but not everyone is. I wouldn't consider myself a great teacher, but there are certain teachers I talk to who just really, really understand how people learn, and those are great things to understand.
Right.
Yeah.
All right, I think so. We'll close here. Thank you, Michael, so much. You're an inspiration, and getting to talk to you, I mean, it's quite. I mean, I get to learn so much, and probably the viewers would get to learn so much. And thank you so much for the experience.
Well, thank you. I had a lot of fun, and yeah, it was really nice to chat with you.
Right. All right. Thanks a lot.